Okay, good evening. This is Professor David J. De Los Reyes. Okay, it's September 14, 2023. The time is around 9:38 p.m. Okay, my topic for this session will be a long video format discussion, and this is on college algebra. We are running smooth on college algebra. We are almost done. This will be lesson number 62. Okay, let's proceed. My topic for this evening will be college algebra, lesson number 62. We are running smooth. We are almost done with college algebra. Okay, and the title of the topic for tonight will be evaluation of functions. Okay, evaluation of functions. For me, it's not a so hard a problem, because for those who are studying engineering, a problem is just a direct substitution one. Sometimes they are laughing. Okay, that is for students of engineering. But since we are talking concepts over here, I will try to present the concepts on the so-called evaluation of functions. Okay, the topic for tonight will be evaluation of functions. Functions meaning it will be an equation, right? Okay, let's try to bring out the procedure and how to evaluate a function. I will try to read the concept, substitute a specified input value to the given function, and simplify. As simple as that one. That's why sometimes when I was teaching engineering in the Philippines, if you try to give problems which are a direct substitution one, students are actually laughing, because it is just a direct substitution one. But since we are studying concept, okay, don't mind them, okay. We will be studying the concept on how to evaluate functions. Okay, so this will be the concept, okay. We are given a function, and the problem is only asking what will be the function if a specified value is given. As simple as that one, right? Okay, let's try to give an example problem. If f of x is equal to 3x squared plus 8x plus 2, am I still on camera? This is the given function, f of x. The given function is 3x squared plus 8x plus 2. Okay? The problem is just asking what will be the value of the function if the value of x is equal to 3. Though there's no hard thing about it. It is just actually a direct substitution one, right? Second value, what will be the value of the given function if the value of x is equal to 1? Third one, what will be the value of the function if the value of x is equal to -2? Okay, let's try to bring out the solution. For the solution, I will place it here, f of 3, meaning when x assumes the value 3 on the given function, what will be the value? As simple as that one. So substituting, okay, the root word here is substitute, right? Substitute. So we'll follow the given function, we'll substitute the value of x, as simple as that one. That's why it is a direct substitution problem. No big deal about it. So it will be 3 times 3 squared plus 8 multiplied by 3 plus 2. Then the last part, simplify. As simple as that one. Right? So this will be 3 squared is 9 times 3, that will be 27. 8 by 3 will be 24 plus 2. Taking the algebraic sum, the answer will be 53. So the given function 3x squared plus 8x plus 2, when x is equal to 3, the value of the function is 53. Okay, as simple as that one. Next one. What will be the value of the function when x assumes the value 1? So according to the rule, just substitute the value, then try to simplify. So this will be 3 times 1 quantity square, we are following this, plus 8 multiplied by 1, right? plus 2. Simplifying, 3 times 1 square will be 3. 8 times 1 will be 8 plus 2. Taking the summation, the value of the function when x assumes the value 1, it will be 13. As simple as that one. No big deal about it. Third requirement, what will be the value of the function when x assumes the value negative 2? So f of negative 2, we will substitute the value of the value that is required when x assumes the value negative 2. So this will be 3 times negative 2 square plus 8 multiplied by 2 plus 2. Simplifying this one, negative 2 square is actually 4 times 3, that will be 12. 8 times negative 3. We are now applying the rules of fundamental operations. A plus and a minus will be a minus. This is negative 16 plus 2. Taking the summation, 12 plus 2 will be 14. 16 minus 14 will be 2. But the negative value is actually bigger, so the answer will be negative 2. So that will be the answer. As simple as that one. Okay, so there's no big deal on the so-called evaluation of functions. It is a direct substitution solution problem. Okay, the other important thing here under functions is the operation of functions. If under the fundamental operations, there are actually 4 operations: addition, subtraction, multiplication, and division. Under the operation of functions, we will be following that one. So there will be an addition of function, right? Subtraction of function, multiplication of function, and lastly will be the so-called division of function. Okay, we'll try to designate the first function to be f. It will be the first function of x. And letter g will be the second function of x. Okay, the fundamental operations, it will be addition. The first one is addition, right? So function f plus function g of x can be simplified as simply the given function of x plus g of x. The operation is addition, right? And the difference in function of f minus function of g of x can be simplified as that given function of x minus g of x. The operation is subtraction. Third one, function of f multiplied by function of g of x. This could be simplified as simply that given function of x multiplied by a dot, a g of x. If you don't want to use the dot, since there is a quantity here, for us to designate the operation multiplication, we will use a bracket, right? So it is understood that we are multiplying function of x to g of x. If you don't want to use the dot portion. What's next? Function of f multiplied by function of g of x. Oh, that's it. That's the one we use. Fourth one, function of f divided by function of g of x. This could be simplified to a function of x all over a g of x. The operation is division, so this is just division. Okay, we put a bracket here, so the operation is multiplication. Okay, those are just the 4 operations under functions. Okay, addition, subtraction, multiplication, and division. It's an easy one, okay? Just substitute values, then try to perform what the operation is being asked. If it's addition, okay, substitute values, then try to add, subtract, multiply, or divide. Okay, let's try to bring out an example problem. So I'm telling you, this is an easy one. But I've been hearing that these problems are coming out on the SAT and CAT exams, so it's a must that we should know how to evaluate functions, okay? There are some trick questions on the SAT problem, so If we know how to evaluate functions, okay, there will be no problem. It depends on what kind of question they will be asking under the so-called evaluation of function. Okay, let's bring out an example problem. Function of x is 3x squared minus 6, and g of x is 4x plus 8. The problem is asking what will be function of f plus g. Next one, function of f minus g. Third one, function of f multiplied by function of g. Fourth one, function of f divided by function of g. So the problem is asking for 4 unknowns, and it involves the operation of functions. Okay, let's try to bring out the solution. Function of f plus g of x, okay? Okay? We are performing addition here. So we will just rewrite function of x, right? Am I still on camera? The operation is addition, so this is plus. Then we will rewrite the value of g of x, which is 4x plus 8. The problem is just asking what will be the sum of function of x plus g of x. That's why I'm telling you it is just a direct substitution one. Right? So simplifying this one, 3x squared, okay, we'll arrange it immediately, so we minimize the steps. Plus 4x, okay, a minus 6 plus 8, that will be a plus 2. Okay, so that will be our answer. So we are just using our knowledge on the so-called fundamental operations to simplify this one, because the problem is just asking what will be the sum of function of x plus g of x, right? And we arrange our answer in the so-called ascending order: quadratic, linear, and pure constant. So this will be our answer. Next one, function of x minus g of x, what will be the result? Oh, we will just substitute the value of function of x. Function of x is 3x squared minus 6. Oh, we don't even have to place the quantity. It is it is ahead of the second one. Minus. The operation is subtraction. Minus. Open quantity. Okay, I place the quantity here. It's very dangerous because the operation is subtraction. We must have to put the quantity. 4x plus 8. Right? Simplifying this one, we'll expedite a little bit. 3x squared minus open quantity 4x, that will be negative 4x. This is minus 6. Minus open quantity plus 8, that will be negative 8. We change the sign of the terms inside the quantity because this is preceded by negative sign. So this is negative 4x, negative 8. Oh, that's fundamental operations, right? So simplifying this one in the so-called ascending order of powers. So 3x squared. Next will be negative 4x. Negative 6, negative 8. We are adding two negative terms. So the value is 14. But since they are both negative, the sign should be negative 14. Okay. So the answer will be 3x squared minus 4x minus 14. As simple as that one. Letter C. What will be f of x multiplied by g of x? Oh, this is the one that's a little bit complicated because we are multiplying two binomials, right? The given function of x is 3x squared minus 6, open quantity, close quantity. Okay, to designate that we are multiplying the two binomials, right? And g of x is actually 4x plus 8. So if we try to multiply this one, still we will use the so-called distributive law, okay, under the fundamental operations. So we'll go ahead with 4x multiplied by the first quantity. Okay, we'll go with the second term 8 multiplied by the first quantity. Okay, then try to expand. 4x times 3x squared will be 12x cubed. Okay, we'll expedite a little bit so we minimize steps. Okay, 8 times 3x squared will be 24x squared. right? Any 4x times negative 6, that will be negative 24x. So actually, as we simplify, we are already uh, placing the orders of x, the powers of x in the so-called ascending order or descending order, right? Next one, we are through with this. So the last one will be 8 times negative 8, that will be negative 48. Okay, so as we write, we are placing the order, the exponent of x in the so-called descending order. This is x cubed, x squared, this is x, and this is pure constant. So the answer will be 12x cubed plus 24x squared minus 24x minus 48, and that will be the answer. Okay. Question letter C is actually a little bit complicated than the first one because first and second are both addition and subtraction, and we are not multiplying. We are not adding powers to the exponent of x, but under multiplication, okay, the exponents are actually increasing because we are multiplying exponents, right? Last part, function of x divided by g of x. Again, direct substitution 1. This is 3x squared minus 6, the given function of x, all over g of x, which is 4x plus 6. And that will be the answer. And if you want to divide this one by using long division, okay, we could bring out an answer over here plus a remainder over a 4x plus 8. Okay. If you want to express your answer as a sum of a partial quotient plus the remainder over 4x plus 8. Okay, but no one is questioning us if we stop on there. Okay, so the answer for the division of f of x over g of x will just be simply the given f of x over g of x, and this will be the answer. As simple as that one. Okay, guys, those are the concepts and example problems under the so-called evaluation of functions. So the next time around, I will be discussing another one. Still an additional topics on college algebra. I think it will be the graphs of functions. So at least we know how to graph a linear equation, a quadratic equation. That will be our next topic the next time around. This is Professor David G. De Los Rios. Good evening, class from Los Angeles.